everyone, this is Srividya, Assistant Professor in the Department of CSIT. Today I am going to discuss insertion sort in C programming. What is insertion sort? The definition of insertion sort and the working principle and the time complexity of insertion sort. So the definition of insertion sort is a simple comparison based sorting algorithm. It builds the final sorted array one element at a time by inserting new each element to its correct position in the already sorted part of the array. The working principle of the insertion sort technique is it divides the list into two categories. So we will divide the list into two categories. One is sorted list and another one is unsorted list. It takes one element from the unsorted part and compares the element with the sorted part. So the time complexity of the insertion sort is, for the best case, it is order of n when the array is already sorted, and in the average and worst case it is order of n square. The space complexity of the insertion sort is order of 1. The process for this is, it's simple to implement and understand, efficient for small or nearby sorted data sets, and the disadvantage here it is due to the large data sets, it's order of n square time complexity, the performance degrades, the array size increases. Let's see with an example what is an insertion sort. Consider the array. So this is your array. So what is insertion sort? As I said, the list is divided into two sublists. One is the sorted list and another one is the unsorted list. So when which one will be in the sorted list? So by default, the element 0, the element that is present at the index 0. So by default, the element that is present at the index 0, see, this is your array name, index 0, that is in the sorted list, and this one is the unsorted list. This one is in the unsorted list. So what we will do? Already the element 2 is in the sorted list and the rest of the elements are in the unsorted list. So now we will take a temporary variable and we will place the element that is at the index 1 in the variable temp. Okay, so by default the index 0, the element that is in the index 0 is in the sorted list, and we'll start from the index 1. So if the element that is present in the index 1, that is 3, that I have placed in the variable that is temp. Now I'll start comparing. Okay, so here temp value is 3. 3 is compared with 2. 3 greater than 2. Condition is true. So 3 is greater than 2. Condition is true. So now this element, obviously that is at its correct position. So no need to swap anything. Just we'll write it as it is. 6, 1, 5 and 4. Now this is your sorted list and this is your unsorted list. So this is your sorted list and that one is your unsorted list. Now after this, again I'll now place the element 6 in the variable temp. So now we will compare again. 3 greater than 6, false. So when you are doing the comparison, you should not start from the index 0, because you have placed this index 2, the element that is at the index 2, in a variable temp. So now if you want to compare, you have to move towards here, from this direction you have to move. That means you have to start from index 1. So now you will compare with 3. And after that you will compare with index 0. So like that you have to move. You should not start from index 0. So 3 greater than 6, false. Next 2 greater than 6, again this is also false. Okay, so again the element 6 is at its correct position. So it is 2, 3, 6, 1, 5 and 4. this is sorted array, and this one is your unsorted array. Now, after this, I'll place in the temp 1. This element will be placed in the temp. So, now start comparison. 6 greater than 1, condition true. 3 greater than 1. So, I am starting from the index 2. Index 2. 6 greater than 1, condition true. 3 greater than 1, condition true. 2 greater than, condition true. So, now this place will become a whole. So, now this element move towards one position towards right. So, it is when we have done the first comparison with the 1, the value that is in the temp with 1 is compared with 6. So, now this element will move towards one position towards right. So, that is 6. Next, 3 is compared with 1. 3 is compared with 1. Now, this element will move towards one position towards right. Obviously, again 2 is compared with 1. This will move towards one position towards right. Next, 1 is at its correct position. Now, this is your sorted list. And 5, 4. This is your unsorted list. Next, what will be the temp value now again? We will place in temp, the next value is 5. So, now 5 is compared with, these are the index positions. 5 is compared with index 3. So, what is the element that is present at index 3? That is 6. 6 greater than 5, true. 3 greater than 5, false. So, we are comparing with the value that is in the temp. So, only one move. So, this will move towards one position towards right. Again, 2 is greater than 5, false. 1 is greater than 5, obviously. Only this one will be 1, 2, 3, 5, 6 and 4. So, now this is your sorted array and this one is your unsorted array. Next, the element that is placed in the temp is 4. Now, 4 is placed in the temp. After this, let's check 0, 1, 2, 3 and 4. Okay, 6, it starts comparing with the index 4. 6 greater than 4, true. 5 greater than 4, true. 3 greater than 4, false. 2 greater than 4, obviously false. 1 greater than 4, again false. So, now this position will move towards one position towards right. It creates a space here. So, this will go here. It is 1, 2, 3, 5, 6. After that, this will go towards one position towards right. It is 1, 2, 3, 5 and 6. No, now 4 is placed. So, after this, this is your complete sorted array. So, this is insertion sort. So, here we will divide the list into two sublists. One is in the sorted list and another one in the unsorted list. So, this is the program. So, what logic can we write here? We have started from 1. Because why we have started from 1? Already the element that is in the index 0 we have kept in sorted list. So, we will start from 1. So, what will be the loop? For I is equals to, we have started from 1. So, we can write for I is equals to 1, I less than n, I plus plus. And how many loops we need here? We need 2 loops. Why we need 2 loops? 1, we are moving towards this direction. When I is 1, I is 2, I is 3, I is 4, I is 5. And again, you are moving towards this direction, towards back. Why? Because whatever the value you are placing in the temp, that you are comparing with the previous indexes. So, one loop you are moving towards this direction and one loop you are moving towards back. So, we need 2 loops here. I is for number of iterations and J is for again swapping, comparisons and swapping. So, for I is equals to 1, I less than n, I plus plus. So, what we have done? After this step, we have started. Next, immediately what we have done? We have placed the element that is at the index 1 in the temp value. So that's what this line. T is equals to A of I. T is equals to A of I. And next, what we have done? So you have compared the element that is at the index temp is compared with the element that is at the index 0. So it is for j is equals to I minus 1, j greater than or equals to 0 and t less than A of j, j minus minus. This is the for loop. So here j is equals to I minus 1. What is I value? 1. 1 minus 1, 0. Next, if you take the condition j greater than or equals to 0 and t less than A of j, j greater than or equals to 0, 0 greater than or equals to 0 and t, what is the value that is placed in the t? First value 3. 3 less than A of 0. What is A of 0? A of 0 we have taken here as 2. 3 less than 2. No, false, right? So it is false and this is AND operator. What is AND? Both the conditions should satisfy. Here 0 greater than or equals to 0 condition is true. But here 3 less than A of 0. 3 less than A of 0 value is 2. 3 less than 2 condition false. This is false. So control will not enter inside. So after this first step, what is the list we have taken? 2, 3, 6, 1, 5, 4. Obviously no sorting was done here. What we have placed directly the element 3 in the sorted list. So next, if you want to print the elements in the array, it's for I is equals to 0, I less than n, I plus plus, printf %ld comma A of I. So with that you will get this sorted array, this one. So we have taken total 6 elements in the list, 0 to 5. So total number of elements in the array are 6 elements. So this is insertion sort. In the next session I am going to discuss quick sort in C. That's all for this session. Thank you.